For Chapter 5, Section 5, we're still dealing with these inequalities, and we're still kind of dealing with this and/or thing, like we were in Section 4. But this time, with absolute value, you have situations that tell you it's an and situations that tell you it's an or. So if you have a less than sign with an absolute value inequality, you have an and situation. And remember, anytime you have an and situation, you're meeting in the middle, okay? So your graphs should come towards each other, and they meet in the middle. So if we look here at example 1, let's just start there, all right? It says the absolute value of m plus 2 is less than 11, which means m plus 2, the absolute value of m plus 2 is less than 11, so m plus 2 has to be less than 11. And if I take m plus 2, inside this absolute value means we also could have got negative 11, okay? Which means we need to consider that situation as well. So here's where that and thing comes in. And the reason I didn't write this inequality symbol here is I want you guys to take a pause and think for a second. The absolute value of negative 11 is 11. But the absolute value of negative 12, which would be smaller than negative 11, would be positive 12, which is actually bigger than 11, which doesn't work for this situation. And that's because when you have a negative, the bigger the digit, the further you are away from the zero, so the smaller the number. But when we're going to take the absolute value of that, we don't really care. So we need to turn that symbol around to make sure it works. Because the absolute value of 10, of negative 10, which negative 10 is bigger than negative 11, is positive 10, which is smaller than positive 11. Which I know sounds weird, it's confusing, but that's what you have to do. Okay, so you have your positive situation, the one that they gave you. So m plus 2 is less than 11. And you have m plus 2 for a negative 11 option. But when you have that negative option, you need to turn your symbol around. You need to turn that inequality sign around. Okay? So you're going to solve them both. I'm going to subtract 2 here. I'm going to subtract 2 here. That leaves me with m is less than 9. Same thing over here. Subtract my 2. Subtract my 2. M is going to be greater than negative 13. Okay, so when you go to graph these, I'll graph this one in blue, and I'll graph this one in purple. All right. I want to put them on the same number line, okay, and you don't have to do them in different colors. I'm just doing it so you guys can see easily. All right, I'm going to put 0 here, and I'm going to count by 2s. 2, 4, 6, 8, 10, negative 2, negative 4, negative 8. I need to go further. Negative 10, 12, and negative 14. Okay, or you could, even a better idea, let's do this. So we don't have to have such a large number line. Let's just put 0, 9, 10, break in my graph. Break in my graph. Negative 13 and negative 14. Okay? So, I'm going to graph each one. So I'll graph my one in blue first. That says m is less than 9. So I have an open circle on 9. And I shade this direction, okay? I'm not going to go all the way because I know I got something going on the other side of my graph. So I'm going to stop until I figure out what's going on over there. So if I graph that one in purple, I have m is greater than negative 13. Well, that goes this way. So the solution to this would be everything between negative 13 and 9. Or negative 13 is less than m, which is less than 9. There's the graph. There's the solution. All right. Okay, pause me for real quick and try 1A and 1B. All right, so if we look at 1A, you're going to break it up into 2. N minus 8 is less than 2. That came directly from there. And then to take care of the negative 2, I would take n minus 8 is greater than or equal to negative 2. Don't forget to flip that sign when you do the negative version. All right, on both of these, you're going to add 8 to both sides. Once you add 8, you'll get n is less than or equal to 10, or n is greater than or equal to 6. All right. So in my closed circle on 10, and I shaded this direction for n being less than 10. All right, and then I came over here and I said n is greater than or equal to 6, so I put my closed circle and I shaded to the right to take care of n being greater than 6. All right, and I don't shade anything past the 10 or anything past the 6 because both of these situations have to be true, so they are only true on the section that they overlap. All right. For 1B, do not overthink this one. Okay, they said the absolute value of 2c minus 5 is less than negative 3. My question for you is, can a absolute value ever come out to be smaller than negative 3? And that is, no, you can't, because the absolute value always comes out to be positive. So if the absolute value is always positive, that means you can't get a number. It's impossible to take the absolute value and get something smaller than negative 3. So the answer to this is no solution, which is often written as that empty set symbol. Okay? If you look at example 2, it says, a recent survey showed that 52% of teens age 14 to 18 believe that students are borrowing too much money for college. All right. The margin of error was within 3.5%. So find the range of teens who believe they're borrowing too much money. All right, so what that means is, however many teens believe that they're borrowing too much money for college, if I subtract that from this 52%, which is like that mid-range, that's the understood value, I should get 3.5 because we're within that, okay? Either above or below, we're within 3.5, okay? So if we're above or below, that means we're talking about an absolute value because we don't care if it's negative 3.5 or 3.5. It's just the difference was 3.5, okay? And if it's within, that means it's 3.5 or less. Okay? And that's the difference from the number of students who said they're paying too much for college and the 52% that was on the survey. Okay? So here's our inequality. Got that. S is equal to number of, well, it's not number. Percent of students. Okay. So we're going to set this up. We have S minus 52 less than or equal to 3.5 and S minus 52 is greater than or equal to negative 3.5. Solve that. So I'm going to add my 52. Add 52. You'll get S is less than or equal to 55.5. And S could be greater than or equal to 49.5. Okay, so my range is 49.5 is less than S, which would be less than 55.5. All Okay, if we look at these problems here, now we're done looking at a less than symbol. We're looking at a greater than symbol. With absolute value of a greater than symbol, that means you have an or situation. Okay, so that means the arrows are going to be pointing away from each other. All right, so let's look at example 3 here. You have 3n plus 6. So I'm going to take 3n plus 6 is greater than or equal to 12. Or we do the same thing, 3n plus 6, turn your sign around, is less than or equal to negative 12. So it's still set up the same way as before. All right. So I'm going to subtract my 6 from both sides. That'll give me 3n is greater than or equal to 6. Divide by 3 to get n alone, and you'll get n is greater than or equal to 2. Or do the same thing over here. So we'll get 3n is less than or equal to negative 18. Divide by 3. N is less than or equal to negative 6. All right. When you go to graph this, negative 7, negative 6. Here's my break in my graph. 0, 1, 2, 3. All right. So I have a closed circle on 2. And I'm going to shade to the left because I want numbers that are larger than 2. I have a closed circle on negative 6. And I shade to the right because I want numbers that are smaller than negative 6. So you can see these are going away from each other. And they should be, because if we have a greater than sign, we have an or situation. Okay, also notice that when you do this, the distance from here to here is the same, and the distance from 0 to here is the same. Okay? So you kind of want to keep that in mind for future references. Hint, hint. It will come in handy. All right. So try 3A and 3B and then check back in with me. All right, so for 3A, you would solve this side and you'll get 2k plus 1 is greater than 7. Subtract your 1, 2k is greater than 6. Divide by 2 and you'll get k is greater than 3. So I came over here and I graphed that and I have an open circle on 3, and if k is greater than 3, I'm going to shade to the right. Same thing over here, but I'm going to turn my sign around and make that a negative 7. So I get 2k plus 1 is less than negative 7. Subtract my 1 from both sides. You'll get 2k is less than negative 8. Divide both sides by 2, and you'll get k is less than negative 4. So again, we have an open circle on negative 4, and you shade to the left because you want numbers less than negative 4. All right? And then 3B is the exact opposite of the last issue we had with that negative being over there. If I have the absolute value of something, that means it's always going to come out to be positive. If I'm positive, that means no matter what comes out here, it's going to be positive, which means it has to be bigger than negative 5, because all positive numbers are bigger than negative numbers. So it means it doesn't matter what I plug in for R. I'm going to get the right answer. So your solution is all real numbers. All right. Here's your homework, 318, 9 through 31 odd.